Hello everyone, welcome to today's session about modernizing Microsoft SQL Server on AWS. My name is Runeet Vashisht. I'm a solutions architect in Microsoft Platform on AWS team. In today's session, I'm going to talk about different options available to run SQL Server on AWS using cloud native functionality. I will start with why you should consider running SQL Server on AWS, what are the different ways in which you can run SQL Server in an optimum fashion. Then I will cover various options to replatform and refactor SQL Server to more cloud-native databases. So why should you consider AWS to host Microsoft SQL Server? At AWS, our customers have been running SQL Server and other Microsoft technologies for more than 14 years now. We offer the best platform for Windows Server and SQL Server for higher performance and reliability. Greater security and identity services are also provided as part of our services. Our customers can get more migration support. They get broadest and deepest capabilities. They can lower their total cost of ownership, and they have flexible licensing options. AWS supports everything you need to build and run Microsoft applications, including Active Directory, .NET, Microsoft SQL Server, Windows Desktop as a Service, and all supported versions of Windows servers. Customers looking to migrate Windows Server and Microsoft SQL Server workloads with AWS can take advantage of various AWS programs and tools for their migrations. Tools like Migration Evaluator can help our customers assess and evaluate their existing SQL Server resources and utilization and provide right-sized and license-optimized instance recommendations for their existing on-premises SQL Server workloads. Migration services such as Cloud Endure or Server Migration Service can help migrate on-premises virtual machines to AWS as is. I'm going to talk more about database migration and schema migration assessment tools in just a minute. Customers can choose to run their SQL Server instances either on self-managed instances on EC2 or Elastic Compute Cloud, or run their SQL Server on an AWS managed service called RDS or Relational Database Service. While running SQL Server on AWS, customers have flexibility to either use license-included SQL Server instances on AWS or bring their own licenses. While bringing their own licenses, customers can choose to run their SQL Server instances either on a shared tenancy or on a dedicated host based on their SQL Server licensing terms. While bringing their own license, customers can keep track of their licensing using AWS License Manager. AWS License Manager allows customers to manage, discover, and report their license usage on AWS. There are a couple of different ways to run and modernize SQL Server in AWS. Broadly speaking, these methods would fall in one of the three categories, that is, rehost, replatform, or refactor. Let's look at rehost option first. Rehost is the ability to take your existing SQL Server instance from on-premises deployment and host it on AWS. You can optimize your lift and shift instance on AWS by choosing right AWS instance types. Amazon EC2 instances are categorized in different instance types. Each instance is built for specific kind of workloads. SQL Server instances are suitable to run on memory-optimized instances. Memory-optimized instances are designed to deliver fast performance for workloads that process large datasets in memory. Memory-optimized instances enable increased cryptographic performance through the latest Intel AES-NI feature. We support Intel transactional synchronization extension to boost the performance of in-memory transactional data processing and support advanced vector extension 2 processor instructions to expand most integer commands to 256 bits. Many of these instances also support instance store. An instance store provides temporary block-level storage for your DB instance. This storage is located on disks that are physically attached to the host computer. These disks have non-volatile memory express or NVMe storage that is based on solid-state drives. This storage is optimized for low latency, very high random I/O performance, and high sequential read throughputs. By placing temp data files and tempdb log files on the instance store, you can achieve low read and uh, write latencies compared to standard storage based on Amazon EBS. Additionally, SQL Server code-based licenses can be optimized by allowing you to specify custom number of vCPUs for bring your own license optimization option. Optimized CPUs give you greater control of your EC2 instances. Customers can specify custom number of vCPUs when launching a new instance to save on vCPU-based licensing cost. For SQL Server workloads specifically, customers can reduce their licensing costs by choosing active vCPUs. For example, an R5 8X instance which has 32 vCPUs by default. But if you want to use 8 vCPUs only, you can choose vCPU count of 8 when you start the instance and save licensing costs by 75%. AWS supports SQL Server deployment not just on Windows but Linux-based platform as well. Running SQL Server on Linux falls under re-platform category and has its own advantages. Let's take a quick look. SQL Server on Linux is the same SQL Server database engine with many similar features and services regardless of your operating system. With every new release of Microsoft SQL Server, Microsoft is trying to get feature parity between SQL on Linux versus SQL on Windows. One of the advantages of running SQL Server on Linux is that there is no additional operating system licensing cost that comes with Windows operating system. All this while you don't have to change anything in your application. Your .NET providers, your OLEDB providers, and ODBC drivers for SQL Server would work as it is. You can still use same management tools such as SQL Server Management Studio to work with SQL Server instance on Linux. Speaking of cost, here is a simple side-by-side comparison of Windows versus Linux cost for a couple of different instance types. Linux distributions such as SUSE or Ubuntu doesn't come with additional licensing cost. You can see the cost difference could be up to 20%. You can run multiple SQL Server instances. This 20% could amount to a large saving when you are running multiple SQL Server instances. The cost difference can go even higher if you take into account reserve instances, another billing construct which passes on additional savings if you commit for longer duration of time. Since SQL Server on Windows and SQL Server Linux has same core database engine, there is a large overlap in the features and functions of the database engine. It is easier to talk about DB engine features which are not supported on SQL Server 2019 on Linux. Few of these unsupported features are merged application, linked servers to data sources other than SQL Server, extended stored procedures, buffer pool extensions, and stretched databases. Essentially, anything which is tightly bound to Windows may not have support. Otherwise, for T-SQL and DB engine features, there is a parity between SQL Server on Linux versus Windows. You should be able to take your existing application and run it against SQL on Linux for most of the functionality. Another way to re-platform your SQL Server instance on AWS is by moving to Amazon RDS for SQL Server. Amazon RDS for SQL makes it easy to set up, operate, and scale SQL Server deployments in the cloud. It is a fully managed, durable database built for enterprise workloads at scale and frees you up to focus on application development. If you compare RDS SQL Server with SQL Server running on self-managed EC2 instance, on EC2, you are expected to patch and maintain your instance and database. You will have to plan, design, and manage high availability and scaling of your instance yourself. With RDS instance, you can set up and configure your database instance with single click. RDS service will be responsible for patching and maintaining the DB's instance and the operating system. You can automate DB backup and configure high availability and scaling for your instance. With the RDS SQL Server, as a developer, you can focus on high-value tasks such as building new features and functionality, high-level DB and query tuning, and database optimization. Feature-wise, RDS supports license-included instances. All supported version of SQL Server can run on RDS SQL Server. You can run Express, Web, Standard, and Enterprise editions of SQL Server. High availability is managed by the service itself. RDS uses either always-on availability group or mirroring depending upon the DB version and edition. You can get both Windows and SQL authentication within RDS instance. Other SQL Server services such as SQL Server Analysis Services, SQL Server Integration Services, and SQL Server Reporting Services are also supported on RDS, but there could be features which may not be supported depending upon whether that feature requires operating system level access or not. List of unavailable features is documented in RDS SQL Server documentation. Another feature of RDS SQL Server is Amazon RDS Performance Insights. It is an advanced database performance monitoring feature that makes it easy to diagnose and solve performance challenges on Amazon RDS databases. Performance Insights allows experts as well as non-experts to detect performance problems with an easy to understand dashboard that visualizes database load. It records the current time, the amount, the type of operations, that is IO, CPU, locking, etc., the current SQL Server statement, and several other session attributes. Over the time, this sample data is used to characterize how sessions are contributing to load on your SQL Server database instance. This can be a very powerful tool to understand your DB usage pattern and identify bottlenecks to troubleshoot performance issues. By default, RDS enables automated backups for your database instance with a 7-day retention period. RDS SQL Server also supports custom native backups to S3 as well. This allows you to import or export your database from RDS instance to native SQL Server instances. RDS SQL Server also supports migration of data in and out of instance using SQL Server Management Studio database publishing wizard. RDS SQL Server instance can be used as a subscriber for transaction replication push subscription. This is a useful feature if you want to replicate data from existing SQL Server Publisher instance to RDS SQL Server. If you prefer to use AWS native services for data migration, we support AWS Data Migration Service or DMS to replicate data from existing SQL Server to RDS SQL Server. The next option is to refactor and modernize your SQL Server database based on data infrastructure with fully managed and purpose-built databases. AWS offers 15 plus purpose-built database engines to support diverse data models, including relational, key value, document, in-memory, graph, time series, wide column, and ledger databases. Refactor SQL Server-based data infrastructure to AWS cloud-native services can translate into savings from licensing costs, improvement in availability, scalability, and performance of your application. Now, SQL Server is a great database, and in many cases, you may prefer to continue to use it as is. Many customers, however, told us that over the period of time, their cost of running multiple SQL Server instances has gone up considerably. Running proprietary databases such as SQL Server means adhering to punitive licensing terms and to be subject to regular audits and lock-ins. All of this adds complexity to running business seamlessly. This is where customers can leverage Amazon Aurora. Amazon Aurora is a fully managed relational database engine that's compatible with MySQL or Postgres databases. It combines the speed and reliability of high-end commercial databases with the simplicity and cost-effectiveness of open source databases. Aurora is part of the managed database service called Amazon RDS. RDS makes it easier to set up, operate, and scale the relational databases in the cloud, as we spoke about it a minute ago. Aurora features a distributed, fault-tolerant, and self-healing storage system that is decoupled from the compute resources and auto-scales up to 128 terabytes per database instance. Amazon Aurora automatically divides your database volume into 10 GB segments spread across many disks. Each 10 GB chunk of your database volume is replicated 6 ways across 3 availability zones. Amazon Aurora is designed to transparently handle the loss of up to 2 copies of data without affecting database write availability and up to 3 copies without affecting the read availability. Another thing, when you talk about high availability and high durability, you naturally talk about the backup process. Another thing that is different and unique about Aurora is that Aurora backup happens continuously. So there is no backup window. There is no performance penalty during the backup process, which many customers usually worry about. The storage node continuously writes snapshots to these 10 GB of storages into S3 along with the logs. And in the event that if you need to restore from a backup process, the hundreds of storage nodes in the storage layer can simultaneously access S3 at the same time and apply the logs at the same time as well. So this allows you to fastest restore time as well. Similarly, because of storage decoupled from compute, Aurora storage scales independently from the compute. Aurora supports up to 15 Aurora replicas on each cross-region cluster, and they will share the same underlying storage as a cross-region replica. Another very powerful feature of Amazon Aurora is fast recovery after failover with cluster cache management. With cluster cache management, you set a specific DB reader instance as a failover target. Cluster cache management ensures that the database in the designated reader's cache is kept synchronized with the data in the writer DB instance's cache. If the failover occurs, the designated reader uses values in the warm cache immediately when it is promoted to the new writer DB instance. This approach provides your application with much better recovery performance. If you are migrating to Amazon Aurora from Microsoft SQL Server, there are two parts to the migration: database schema and the data itself. SCT or schema conversion tool allows you to convert DB schema from commercial database to AWS native database such as Amazon Aurora. It can assess your existing database and generate a report of objects which can be converted to corresponding objects on target database. And it can also flag out objects which don't have corresponding mapping in the target database. AWS Data Migration Service or DMS helps you migrate database to AWS quickly and securely. DMS supports homogeneous migrations such as SQL Server to SQL Server, as well as heterogeneous migrations between database platforms such as from Microsoft SQL Server or Oracle to Amazon Aurora. You can set up DMS tasks for either one-time migration or for ongoing replication. As an ongoing replication task, DMS keeps your source and target databases in sync. Once set up, the ongoing tasks will continuously apply source changes to the target database with minimal latency. While SCT and DMS can help you migrate SQL Server schema and data from SQL Server to Amazon Aurora, there is another integral part which has to work. It is the applications. Most of the applications are built to work with specific databases, and if an application is built using SQL Server, moving the DB to anything other than SQL Server can potentially break the application. If the application still works, you can see unexpected results due to the difference in which databases handle different data types. For example, money data type in SQL Server works very differently from Postgres. Minor differences in data types could make a big difference in application's functionality. Now imagine if you could migrate data from SQL Server to Amazon Aurora, while your application can connect to the same DB instance just the way it connected to SQL Server without requiring code changes or DB provider or driver for the database. That's where we introduce Babelfish for Aurora Postgres. Babelfish for Aurora Postgres is a new compatibility for Amazon Aurora Postgres. that enables Aurora to understand commands from applications written for Microsoft SQL Server. Let's go a bit more into the details of what is Babelfish. It is an Aurora Postgres extension which provides T-SQL capabilities to an Aurora Postgres instance. The Babelfish endpoint supports TDS or Tabular Data Stream, SQL Server's wire protocol, enabling applications to connect to Aurora using SQL Server drivers. It is an open source project built together with a diverse community of contributors. Additionally, Babelfish endpoint is an additional endpoint for an Aurora Postgres instance. It is not a separate server in itself. It is also not a proxy or additional layer. It uses extension model of Postgres. Intention of Babelfish is to not replace Postgres. Consider this as a mechanism to accelerate your migration from SQL Server to Amazon Aurora Postgres. Without going into the complete list, Babelfish is expected to support often used SQL Server features such as triggers, stored procedures, and views. It supports T-SQL transactions and semantics. We support multiple SQL Server data types as well. Additionally, you will be able to create table data types, table valued functions, static cursors, etc. Our goal with Babelfish is not to have a feature parity with SQL Server, but to have an accuracy parity for the data types and features that we support. You can look at the complete list of features on Babelfish documentation as well. Now, if you need to assess and determine if your database is compatible with Babelfish, before starting your migration, you can do the assessment using a couple of different options. The first one is using an open source tool called Babelfish Compass. It is an Babelfish compatibility assessment tool, a standalone CLI tool. It can be downloaded and you can run it against your SQL Server database schema, and it will give you a report about how many existing objects are compatible with what is supported by Babelfish. Additionally, you can also use schema conversion tools assessment feature for Babelfish, which is going to do a similar assessment for you, but it is only going to do a read-only assessment and not generate any converted code. Last but not the least is a service called Migration Hub Strategy Recommendation Service, or MHSR. This is a service which sits in the Migration Hub service, and it can, under the cover, use Babelfish Compass tool for you and do the assessment and generate output report for you. Migration Hub Strategy Recommendation Service is particularly helpful if you have to do assessment across multiple databases and multiple database instances in your existing environment. And this can be your on-premises environment running SQL servers, or it can even be SQL Server running on Amazon EC2 instances in AWS. With that, we have come to the end of the session. I hope the information provided in the session was useful. Thank you so much for your time.